This video covers the worksheet titled Polynomials, Evaluate and Classify. It's the introduction to the Polynomials unit, and it follows along with questions that should have been answered by the notes that you took in a previous video. So, the essential question on this worksheet is, how do I evaluate and classify polynomials? How do I evaluate and classify polynomials? So open up your flip book to that section. I believe it might be the back flap, but I'm not sure about that. But open up that section and use that as help as you go through this worksheet. First section says the following expressions are in standard form. Remember, when we're talking about standard form, we're talking about taking the polynomial expression and putting it in order from the highest exponent to the lowest, and then if there's a number that doesn't have a variable on it, that is called the constant, and that goes on the end. So hopefully you're understanding these terms. Coefficient is a number that is on at the front of a monomial. And so let's talk about the first one, negative 5x to the 6th plus x squared. So I'll give you help on the first one, and then we'll see if you can do the rest of them on your own. All right, so the question says, what is the name? And that name is based on the number of terms. We've got 2 terms here. Remember, terms are always separated by adding or subtracting. So here's a term, and here's a term. So we've got 2 terms, which means this is called a binomial. Now, just so I don't confuse you, technically this is a polynomial as well. Remember, your definition of polynomial is an expression or equation with more than one term. So I'm going to put here, this is also a polynomial. So binomials, trinomials, those are both also polynomials. A monomial is not considered a polynomial because it only has one term. All right, so what's our degree? We learned in the degree section of our notes that the degree is it's the highest exponent on a term, or also, class, we learned that with monomials, if we have a term that has more than one exponent, we would add those together. But you don't add the exponents together of separate terms. You just look at each term and decide what's the exponent on this term? It's a 6. What's the exponent on this term? It's a 2. And that means our degree is 6 because that's our highest degree of each of those monomials. And then the leading coefficient, well, we're already in standard form. Standard form shows us that the leading coefficient is always on the first term because that's the term with the highest exponent. If these terms were not in standard form, you would have to put them in standard form, and then your leading term would be the first coefficient that you would see. So in this case, our leading coefficient is negative 5. Now, I want you to take a moment, pause the video, and go ahead and try to do the next 3 on your own. So pause the video now. All right, hopefully you've given this a shot. Let's take a look at this. The first one, we've got 1, 2, 3, 4 terms that are separated by adding and subtracting. So that means this is not a monomial, it's not a binomial, it's not a trinomial, so it's none of those. So we're just going to call it a polynomial. What is the degree? Well, let's take a look. On this term, all the exponents add up to 3. This one 2. This one doesn't have exponents, and this one is a constant which doesn't count. So our degree here is 3. And then the leading coefficient, well, there's not a number out here in front of our first term. Class, you should know multiplication rules. If we multiply anything by 1, it doesn't change the original thing. And so even though there's not a number here, we can imagine that there is actually the number 1 in front of this. So our leading coefficient is actually positive 1. On the next one, now we only have one term. There's no adding or subtracting here. I want to make you aware, just because there's a minus sign in front, if there was one, that doesn't mean we're adding or subtracting. In that case, that just means it's a -4. But in this case, there are no additional terms. That means this is a monomial. And since it only has one term, it's not a polynomial. The degree here is 4. Sorry, correct myself on that. Let's take a look. When we get degrees, we look at each term and then add the exponents on the variables. So we've got 2 plus 3 is 5, so the degree here is 5. And then the leading coefficient here, there we go, that's going to be a 4. Last one, we've got 2 terms. Here's a term, -3x to the 4th y. Here's a term, +9x squared y. So we've got 2 terms. That means we are looking at a binomial. And if we look at binomials, we also know there's more than one term, so that also could be called a polynomial. The degree here, let's take a look. On this first term, even though we have a variable y, that exponent is implied. There is an exponent of 1 there. It's the same as having 1 as a coefficient. If there's no coefficient, that means there is a 1, we just don't have to write it. Same thing on an exponent. Y to the first power is just y. So there is an exponent there and an exponent there. Let's take a look. On our first term, the degree is 4 plus 1 is 5. On the second term, the degree is 2 plus 1 is 3, so our degree is 5. That's the highest number that we have as a degree on each term. And then the leading coefficient here is in the first term, and that is -3. Now the question would be is, why do I have these in this particular order? In this case, it gets a little more difficult when you have multiple variables. Traditionally, you would put the highest exponent at sum of the exponents first and then work your way down to the end. Alright, so there's your first help. Hopefully you got those answers right, and if you did not, you verified where was your misunderstanding so you can have that understanding corrected. I encourage you also, class, on this first worksheet we're doing, if anything is covered on this worksheet that's not in your notes, you can add notes to your flipbook. Put it in the margins, write it somewhere, put a star next to it, make it colored, just something that helps you remember something that the notes maybe did not help you on. Those are for you to use throughout this course. So write extra stuff in there if that's going to help you. Alright, I'll try to quickly go through this. I kind of cover for you something that you already covered in your notes. How do you evaluate an expression? Remember, an expression is a list of terms or a term without equal sign. And this means, what is this expression value going to be if x were equal to -1? And remember, we talked about this in the video. Whenever you replace a variable, you should get used to putting that in parentheses. The biggest reason why is it'll help you not make a mistake when there's negatives or positives or exponents in your equation. It also allows you a nice way to put it directly in your calculator. If you insert your variables in parentheses, you can actually type this expression directly in your calculator and it would give you the answer 6 if you did it right. I would, if I were you, try that out and make sure that when you put this in your calculator, you get the number 6. If you're looking for a calculator to use, you can go to my website. There's a link to that in your resources and click on calculator and it will bring up this calculator right here. And you can go ahead and put your information in. Let's do this one right here to show you. 3 parentheses, then we had a -1. And if you look at this, I'm not going to use the minus sign because minus means we're subtracting. We're not subtracting 1. We're multiplying 3 times -1. So you use the plus or minus sign for that. So I'll put a 1, close parentheses. You'll see a button here for squaring. It'll look like a little caret and a 2. That means raised to the power of 2. Now we're going to subtract, so we have to use the minus sign. 2, then in parentheses we use our negative value, negative 1, and then we're going to add add 1 to that. So now I check my equation. It looks just like I typed in there. Press equal, and you see you end up getting 6. So that calculator can be a big help to you. Last part here is just going over what is the definition of like terms. Like terms have the same variable or variables with the same exponents. Here's a list of what I consider like terms. These are absolutely not like terms. So you cannot add and subtract these, but you can add and subtract these. All right. Now I'll let you know on the bottom of all the worksheets you will have an answer key, so you can check your work as you go to verify that you've got the answers put in there correctly. So usually this answer key is printed upside down, so you don't just keep glancing at it, but definitely as you go check your answers. If you're getting wrong answers right away, you better go back and check your notes or check your video to figure out what you are doing wrong. Okay, write the expression in standard form. I'll do the first one here, just showing this. Actually, I won't do it. I'll just talk to you about it. Remember, standard form, we take the highest exponent. This will be our first term that we're going to write. Notice that the minus sign is part of that term. So your first term will be negative 2x cubed. Our second term will be the next exponent down, positive 6x squared. Our third term will be our next exponent down. Remember, this is actually x to the first power, so that goes third. And then our constant goes fourth. So rewrite that in that order. Check your answer key. The rest of these you can check out on your own. Number 3, again, can be a little confusing here. In this case, if you look at this, the degree of this monomial is 3 plus 1 is 4. That would go first. 2 plus 1 is 3, that would go second, and 1 plus 1 for our two exponents is third, so that would go third. All right, let's take a look at the next part. Group the like terms in separate boxes. So all I'm asking you to do here is look at the equation, find the like terms, and put them in the same box. So you'll see, in this case, this is a like term with this one. You can write those two in this box. This is a like term with this one. That can go in this box. And in this case, we don't have a third like term, so we won't use the third box. On the next one, the same thing. Group all the like terms in this box, like terms in this box. If there's another like term, put it in the third box. If there's not, you can ignore it. All right, let's go to the next column. Evaluate the following expressions. Okay, again, in every situation, you're going to put this in your calculator just like you write it. So I expect for you to get good at showing your work. There are way too many students, and I'm going to tell you, I'm one of them, who would look at this equation, stick it in my calculator, or do it in my head and write the answer. I want you guys to stop doing that and start getting in the habit of writing your work. Okay, I know it's going to take you an extra few seconds, but it's going to train your brain to plug variables in correctly and use your calculator correctly. So the way I would do this one is I would write, okay, I'm going to plug this 2 into this x term. So this is what my calculator is going to look like. 3 times 2 minus 6. And now I'm going to go ahead and put that in my calculator. I've got 3 parentheses 2 or times 2 minus 6, press equal, and I've got 0. So my answer here is 0, and then I'd love to get you in the habit of, when you're showing work, always circle or put a box around your final answer. Actually, that circle looks weird because it's a circle around 0, so I'll put a box around it. All right, for every one of these, you'll be doing the exact same thing. Now, when you get to number 8, I want to give you some help on this because I know there'll be questions. I get it all the time. Mr. Z, what do I do when I have a fraction? Well, a fraction just means numerator divided by denominator. So the way I always do this is when I put fractions in my calculator, I will always force parentheses around them so the calculator does not get confused on the rules of PEMDAS. It will know that this is a specific value. So when you put this in your calculator, here's how you would do it. You'd put in parentheses 1, and then if you look at your calculator, you've got a divided by sign right here. So I'm going to go ahead and put 1 divided by 2. There's my fraction. Now I'm going to plug in my variable, -2. And now I'm going to plug in my variable here, -2. I guarantee you, if you write this out correctly and use your parentheses correctly, specifically around fractions and your variable, you put this in your calculator, boom, you're going to get the correct answer. All right, number 9. Number 10. Number 10, the confusion could be, do I have to put my variable in parentheses? I'll tell you, the only issue is the parentheses start to get confusing. But I would say just to train yourself to do this every time, you're going to notice that sometimes I'll skip this, but I would say train yourself to do this. There's the parenthesis that came with my equation. Now I'm going to show you, you would put in parenthesis 3, close your parenthesis, and then -1. And then you would put in your next one, and there's my parenthesis 3, close parenthesis, and then I've got +4. So now you've got parentheses inside of parentheses. The hardest part here is keep track of your parentheses or you will get an incorrect answer. Always check your calculator display before you press enter so that you know that you've put your equation in there correctly. All right. And by the way, you probably can see this is easily done in your head. You could just do 2 and then 3 minus 1 is 2. So 2 times 2, 3 plus 4 is 7, 2 times 2 times 7. But get used to using your calculator also so you learn how to do more complex things later. All right, that covers the front of the page. Let's, as quickly as we can, get to the back of the page. And I know a bunch of you are thinking already, really? First worksheet, Mr. Z, I got word problems? And the answer is yes, you do. So read the question carefully. I'll guarantee you that when I give you word problems, there's nothing in that word problem that you haven't already learned how to solve. You just got to relax, take a deep breath, and read the question carefully. Lisa is measuring the depth of a well. She drops a ball from a height of h feet, so now I know what h represents, into the well and measures how long it takes the ball to hit the bottom of the well. So here we go. Picture this in your head. She's raising a ball above her head. She is dropping the ball into the well, and we're going to see how long it takes to hit the bottom. Now, they give you a polynomial that represents exactly how high the ball is at any point in time. It says, I've got this polynomial. It models this situation where 0 is the initial or starting speed. It's right there. H is the height the ball was dropped from. There's our H value. And T is the time it takes to hit the bottom. So if you know time, and you know initial velocity or speed, which is right here, and you know H, you can plug all those in. Look at that. We'll have T here, we'll have H here. You can plug that in your calculator. Just like you evaluated the last couple, you can evaluate this expression and come up with a value. So she raises her arm high and drops the ball from a height of 6 feet. So class, what is the variable here? What does 6 feet represent? Represents the height. The height above, or height above the well. She drops the ball from a height of h feet. So there's our h value. So the first question is, write the simplified polynomial expression. I give you a hint here. Substitute the initial height of 6 into h, and then simplify the expression. So all you're going to do is take the expression you're given, rewrite it, but instead of writing h, you'll plug in 6. And then the only variable left is t. Now, you may have the question, Mr. Z, do I have to leave this term here? Does this have to be left in my equation? Because most of you know, hopefully all of you know, that 0 times anything is just 0. So if you want to, you could actually remove this from the expression. If you don't, it doesn't matter. Your calculator will handle the 0 times the time. but if you want to remove it, you can. So the simplified expression, you can write it with the middle term in here and plugging in h, or you can write it just negative 16t squared plus 6, and you are good to go. And then the last thing it says is Lisa drops the ball and it takes 3.5 seconds to reach the bottom of the well. What is the variable for 3.5 seconds? Let me change that color so you see this. Hopefully all of you have already looked at the question and said, oh, Mr. Z, it's right here. There it is, t. So now look, you've got an expression, and you know t. T is the only variable. You can plug 3.5 seconds or 3.5 into your expression, and you will figure out how deep the well is. And then last thing, think about this. We're actually dropping the ball from somewhere above the air or above the ground, and now it's dropping, so you're going to notice you're going to get a negative value here. And the question is the depth of the well a negative value? And the answer is, you know better than that. There's no such thing as negative distance. So when you write your well depth, even though your answer is going to be negative, you'll write this as positive number, and then make sure you write your unit of measure. Look at your equation or your question and ask yourself, what's the unit of measure here? All right. Same kind of question. I'm going to let you go through this and try to figure this out. It's asking you how much Claire charges for a 6-foot painting. It gives you a variable that represents the height of the painting or the size of the painting. And then how much does Rich charge for a 5-foot painting? You should be able to figure that out. And then last one here, question number 14. Again, just read the question carefully. You're given 2 polynomials, or 2 trinomials, and 2 different temperatures. The only thing you want to be careful of is I want you to see when I know there's something you better pay attention to, I will have it underlined. In this case, t is time in seconds. But in the question, they give you time in minutes. You should all know how many seconds are in a minute. I would write that here because you're not going to plug 1 in for t. You're going to plug how many seconds are in 1 minute. So how many seconds are going by. And then here, what's the population at 20 degrees? That'd be a certain polynomial you would use from your equation or from your question. And then if it's 30 degrees, you use the other polynomial and you figure it out. And then, last thing on every worksheet, when you have exit questions, class, I expect you, and it's good for you to answer this. They'll typically be very easy questions. They're just making you write in words what you know about this particular question. Get yourself trained to answer those. I will confess I was a lazy student a lot of times and I would skip that part. I figure, well, that's not the part I'm learning, and I'm telling you, my exit questions are designed for you to think through something that you just did in the worksheet or in a question and answer it in a complete sentence. So write out a sentence. I guarantee you these will typically take no longer than about 60 seconds to do, and it will help your learning. All right, that's it for your help. You should be able to finish this worksheet successfully, and if you have any questions, you can ask me in class. All right, bye-bye.